Every second, 3,170 packs of instant noodles are consumed worldwide. That's over 100 billion packs annually. But have you ever wondered how factories manage to produce 4 million packets daily to meet this staggering demand? In this documentary, we're taking you inside the massive production facilities where wheat flour transforms into those familiar curly noodles. You'll witness the precision engineering and scientific processes that most consumers never see, from dough preparation to the final packaging of this global food phenomenon. The journey of instant noodles begins long before they reach your pantry. Every day, massive processing facilities receive tons of wheat from farms across multiple countries. These factories never stop. They operate 24 hours a day, 7 days a week, turning raw wheat into millions of noodle packets that will eventually find their way to consumers worldwide. As truckloads of wheat arrive at the factory gates, the manufacturing process starts with rigorous quality control. Sophisticated systems analyze thousands of wheat samples every hour, examining each batch for specific characteristics. The most critical factor is protein content. Wheat with inadequate protein levels gets rejected immediately, as it won't produce noodles with the proper texture and bite that consumers expect. Maintaining consistent flour quality presents a significant challenge for manufacturers. Wheat harvests vary seasonally and geographically, with protein content fluctuating based on growing conditions in different regions. A factory might receive wheat from North America in one shipment and Australian wheat in the next, each with slightly different properties. Quality control technicians continuously adjust their parameters to account for these natural variations. Once accepted, the wheat enters the industrial milling process. Enormous mechanical rollers crush the kernels, while a series of progressively finer sieves separate the components. Advanced optical sorters scan the material at high speeds, removing any impurities, from tiny stones to damaged grains, at rates reaching 10 tons per hour. This process transforms the wheat kernels into the fine, consistent flour needed for noodle production. Storage capacity at these facilities is equally impressive. Each factory maintains enormous flour silos that tower several stories high, holding up to 500 tons of processed flour. This quantity provides enough raw material to produce approximately 5 million noodle packets before requiring replenishment, ensuring continuous production without interruption. Before entering production, the flour undergoes final testing in the factory laboratory. Technicians measure moisture content, protein levels, and gluten strength, all critical factors that determine how the noodles will form and cook. Computer systems process this data and adjust formulations in real time, adding precise amounts of various flour types to maintain consistent quality despite natural ingredient variations. Water plays a crucial role in noodle quality that most consumers never consider. Factory water systems purify up to 50,000 gallons daily, removing impurities while carefully calibrating mineral content. The specific mineral profile significantly affects the noodle's final texture and cooking properties. Too soft or too hard water produces noticeably different results when the noodles are eventually cooked. 2 additional ingredients arrive at factories in industrial quantities: salt and kansui. Kansui, an alkaline mineral water, gives the noodles their distinctive yellowish color and chewy texture. Automated dispensing systems measure these components with remarkable precision, accurate to within 0.01%, ensuring consistency across millions of noodle packets. Even tiny variations in these ingredients would noticeably alter the final product. The perfect noodle dough emerges from a precise ratio of flour, water, salt, and kansui. Industrial-scale mixers combine these ingredients in 500-kilogram batches, with computer-controlled systems monitoring every aspect of the process. The mixing time, blade speed, and even the temperature of the mixture receive constant adjustment to achieve the ideal dough consistency. As we observe the massive mixing operation, the raw ingredients transform into a cohesive yellowish dough, still far from resembling the familiar noodle shape. Conveyor systems transport this dough to the next production area, where the real engineering precision begins. This simple mixture will soon undergo remarkable mechanical transformations, stretching, flattening, and cutting into the distinctive wavy strands familiar to instant noodle consumers worldwide. Moving deeper into the factory, we find ourselves in the core production area where the transformation truly begins. Massive industrial mixers have already combined the ingredients, creating a yellowish dough that bears no resemblance to the noodles we recognize. This dense, elastic material now requires careful processing to achieve the proper texture and form. The dough first undergoes a critical resting period. During this time, the gluten proteins in the flour develop complex networks that give noodles their characteristic chewiness. Factory sensors continuously monitor these protein changes that remain invisible to the human eye, measuring minute shifts in the dough's elasticity and resistance. This resting period typically lasts between 30 to 45 minutes, with technicians adjusting the duration based on humidity levels and flour properties. Creating consistent noodle sheets from this dough presents significant engineering challenges. The production line must maintain precise dough thickness while operating at remarkable speeds, up to 60 meters of dough sheet per minute. At this velocity, even minor variations can result in thousands of defective products, making precision engineering essential to the operation. Industrial rollers transform the dough through a series of compression stages. These massive metal cylinders apply over 500 pounds of pressure, gradually reducing the dough thickness from an initial 10 millimeters down to less than 1 millimeter. The dough passes through multiple roller pairs, each set closer together than the previous one. This gradual compression prevents tearing while developing the gluten structure that gives instant noodles their distinctive texture. Temperature control throughout the sheeting process remains critically important. The entire production area maintains temperature variation within just 2 degrees Celsius. This precision exists because even minor fluctuations alter the dough's elasticity and final texture. Cooling systems built into the rollers prevent friction heat from affecting the dough as it passes through at high speeds. Factory engineers continuously monitor the production parameters, balancing speed against quality. Faster production increases output volume but risks compromising the noodle's structural integrity. Throughout each shift, technicians take samples from the line to test elasticity, thickness, and moisture content, making adjustments to maintain consistent quality. The dough sheets travel over 100 meters through the production line on a complex system of conveyor belts. Optical sensors positioned at 20 different points along this journey check the thickness using laser measurement. These sensors connect to a central computer system that automatically adjusts roller pressure to maintain uniformity throughout the enormous dough sheets. One of the most recognizable features of instant noodles, their wavy pattern, comes from specialized rippling rollers. This distinctive shape isn't simply aesthetic. It serves an important functional purpose. The waves increase the surface area of each noodle strand, allowing for faster cooking and better broth absorption when the consumer prepares the product. The pattern also prevents noodles from sticking together during processing and in the final package. The transformation from sheet to noodle happens in a fraction of a second. Advanced cutting technology slices the continuous sheets into individual strands at astonishing speeds, exceeding 8,000 cuts per minute. The cutting blades operate at carefully controlled temperatures to prevent the dough from sticking to the metal surface. Each blade must maintain perfect alignment to create uniform noodle width, with the cutting mechanisms adjusting automatically to compensate for any wear. As the freshly cut noodles travel forward on conveyor belts, they've completed their transformation from amorphous dough to recognizable noodle form. The strands move in perfect alignment, ready for the next critical stage in the process. These fresh noodles still contain significant moisture and lack the preservation qualities needed for shelf stability. They're about to undergo another transformation through heat processing that will give them their signature texture and extended shelf life. The crucial steps that make instant noodles truly instant. The freshly cut noodles next enter massive steam chambers where temperatures reach 100 degrees Celsius. This stage initiates a molecular transformation invisible to our eyes, yet crucial to creating the final product consumers recognize. Inside these industrial steam tunnels, a fundamental change occurs in the structure of the noodles at the microscopic level. Steaming triggers a process called gelatinization within the noodle strands. During this reaction, the starch molecules absorb water and swell, breaking down their crystalline structure. This transformation changes the internal composition of the noodles and prepares them for the subsequent dehydration step. Without proper gelatinization, the noodles would never achieve the right texture when consumers rehydrate them later. Timing in this steaming phase proves absolutely critical to product quality. Engineers carefully calibrate the duration based on precise calculations. Too little steam exposure leaves uncooked starch molecules intact that won't properly rehydrate when the consumer prepares the noodles. Conversely, excessive steaming creates soggy noodles that crumble during packaging and transportation. Factory technicians continuously monitor the steam chambers, adjusting temperature and humidity levels to maintain optimal conditions. The scale of these industrial steam tunnels impresses even seasoned food manufacturing professionals. Each tunnel processes up to 1,000 kilograms of noodles per hour on continuous mesh conveyor belts. The noodles remain in the steam environment for exactly 5 minutes, with the specific duration depending on their thickness and formulation. Thicker noodles require longer steaming times to ensure heat penetrates completely through each strand. After emerging from the steam chambers, the noodles contain approximately 30 to 40% moisture content. This level must be reduced to just 2 to 5% to achieve long-term preservation and storage stability. Without this moisture reduction, the noodles would quickly spoil and develop mold. The dehydration stage represents another critical engineering challenge in the production process. The most common dehydration method employed by manufacturers involves flash frying in palm oil. Large industrial fryers maintain oil temperatures between 140 to 160 degrees Celsius. This rapid high heat exposure creates the characteristic porous structure within the noodles that allows for their quick rehydration later. The countless tiny air pockets formed during frying provide channels for hot water to penetrate quickly when the consumer prepares the product. During the frying process, the noodle blocks pass through approximately 2,000 liters of continuously filtered oil. The entire frying phase takes just 1-2 minutes as moisture rapidly evaporates from the noodle structure. The oil undergoes constant filtration to remove particles and prevent flavor transfer between batches. Quality control systems monitor oil quality parameters, automatically replacing oil when it fails to meet specifications. Some manufacturers, responding to health-conscious consumer segments, use air drying technology instead of oil frying. This alternative method takes considerably longer, 30-40 minutes versus 1-2 minutes for frying, but reduces the oil content in the final product from 15 to 20% down to just 3%. These air-dried noodles offer different nutritional profiles while still achieving the necessary shelf stability. The steaming process plays an essential role beyond just starch gelatinization. It effectively pre-cooks the noodles, making them shelf-stable for months or even years while ensuring they can be fully rehydrated in boiling water in just 2-3 minutes. This remarkable reduction in preparation time compared to traditional noodles constitutes the key innovation that made instant noodles revolutionary when first introduced. While the processed noodle blocks cool and solidify on conveyor systems, another sophisticated operation runs in parallel. This involves the creation of the flavoring packets that give instant noodles their distinctive taste profiles. In separate production areas, machines combine dehydrated vegetables, seasoning powders, salt, flavor enhancers, and other ingredients in precise formulations. These packets get sealed individually before joining the noodle blocks in the final packaging. The cooling noodle blocks now exhibit the familiar wavy pattern and porous texture that consumers worldwide recognize. Their journey from raw ingredients to nearly finished product has involved multiple precise engineering steps, each critical to creating the convenience food that millions prepare daily. As the noodles approach the packaging stage, they've transformed from simple flour and water into a shelf-stable food designed for rapid preparation. The journey from raw wheat to packaged instant noodles reveals an industrial marvel of food science that most consumers never consider during their 3-minute preparation time. This complex manufacturing process combines centuries-old culinary traditions with modern production technology, producing billions of affordable meals annually. The economic impact is substantial, with Nissan alone reporting over 450 billion yen, approximately $4.3 billion, in revenue in 2019. The industry continues evolving to address consumer concerns by launching products with lower sodium content, increased fiber, and gluten-free options. As Momofuku Ando, the inventor of instant noodles, stated, "These products were designed to help end hunger, a vision realized through global adoption.